Hello and welcome to your lesson on alkenes and alkynes. Today we're going to learn about some unsaturated hydrocarbons, learning how to name them, and then also doing the formulas, writing out the structures, that sort of thing. So getting into it, let's talk about actually the naming first, and then we're going to get into some drawing of these unsaturated hydrocarbons so you can see how that works. So for naming, it's basically what you learned for alkanes. So if you don't remember that, go back to the alkanes video and how to name them. But you're dealing with the same kind of base system for doing the naming. The difference is the ending. Okay, so with alkanes, we had an ane ending. And that makes sense, right? Alkane, and then you put the ane at the end of the name that you're making. Well, for alkenes and alkynes, alkenes being double bonds and alkynes being triple bonds, we put the ending as ene or ine, and that's how we actually show that we have a double or a triple bond. Now, when we do that, we also put the position of the double or the triple bond in the name as well. So we put a number in there, but that's the base. That's kind of like what we're doing is alkanes, but with a different ending and putting the numbers. The only other difference we need to talk about is that the parent chain must include the double or the triple bond. So even if it's not the longest, it has to include that double or triple bond. And then also that the numbering is done in such a way that we reach the double or triple bond at the lowest number possible. So the double or triple bond takes priority over the chains or the branches, over the branches in terms of priority to getting to the lowest number possible. So when we're doing our numbering and figuring out, do we go left to right or right to left or what we do, when we're doing that numbering, we have to just consider, well, which one reaches a double bond at the lowest number possible or the triple bond at the lowest number possible. And then once we figure that out, if there's a tie in both directions, then we start considering the branches. So that's essentially what I just talked through here. That's what this says. Again, you have the notes in your workbook, so you can take a look at that and learn from there as well. So name branch positions and size of the branches the same way as in alkanes. And then when we look at the end, we're going to put the multiple bond position number immediately after the number of carbons in the parent chain. So if we had 4, but, right? And then we'd have the number of where the double or the triple bond is. And then we'd use either ene or ine at the end, ene for a double bond and ine for a triple bond. So like anything else, really where you're going to learn about this is from the examples, right? Once you see this done a few times, then I think you're probably going to be all set and good. So when I take a look at 1A, we can tell that this has a double bond right here. So this is going to have an ene ending. Yeah, it's not an alkane, it's now an alkene. Now, just a quick word about unsaturated. What unsaturated means is that I could add more hydrogens to it. So as soon as I have a double or a triple bond, it now has spaces where hydrogens or something else could be added to the compound. So we call that unsaturated. If we have an alkane where we have only single carbon-carbon bonds, well, then that is saturated. It can't have anything else added to it. So that's the difference, right? Saturated can't have anything else added to it by reaction, and unsaturated it can. So I could add hydrogen or something else to here. And as you can see in the hydrogenation reaction we do in a bit, it could add to that double or triple bond location in order to add more hydrogens to the structure. But I'm getting way ahead of myself. Let's just get into the naming here. So I see that I have the double bond right here. So when I number, I could go left to right, 1, 2, 3, 4, or right to left, 1, 2, 3, 4. And left to right is the obvious best choice because then I get to the double bond on carbon number 1 instead of carbon number 3, right? 1, 2, 3. So that is the better choice. So given that I have 4 carbons in that parent chain, it's but. I messed that up, sorry. But. And then I have a double bond on carbon number 1, so it's but 1, and then ene. So this number 1 is saying that I have a double bond on the first carbon, and I always use the lowest number that the carbon is that actually is participating in the double or the triple bond, so 1. And then ene, that E is specifying that I have a double bond. Again, notice that I have hyphens in between numbers and letters, right? So whenever I have a number from a letter and it's changing over, crossing over between numbers and letters, I need to have a hyphen to show that. All right, B, really similar. See if you can get that one. And the answer for this is 1, 2, 3, 4. So I have a double bond on carbon number 2. So it's butene. Okay, now if I went right to left, it would still be 1, 2, 3, 4. So either way, it doesn't matter. If I'm going left to right or right to left, it gets me the same numbers. So either numbering is fine. Something to say around this one is that these two compounds are actually separate compounds. Okay, so these do not have the same chemical properties. They are different, even though they have the same number of carbons and hydrogens. These are isomers. Okay, so same formula, but different structure. So interesting. And this kind of introduces that idea that we can tell if things are isomers by naming them. And if they have a different name using the system, then we know that they are isomers. And if they don't have a different name, then they are not isomers. And again, you know, given that it has the same formula, the same number of carbons and hydrogens. All right, let's take a look at this one. So if I do my numbering, I have 1, 2, 3, 4, 5 from right to left. That gets me to a double bond on 2. The other direction is 1, 2, 3, 4, 5, which gets me to a double bond on 3. So left to right is the right direction, even though I don't get to a branch until 3 this way, and 2 right to left. The double bond has higher priority than branches in numbering. So that means that I have an answer of 3, 4, because I have a branch here and here, dimethyl. Then I have 5 carbons, so it's pent, 2-ene. Okay, so 3,4 dimethyl pentuene. For D, this one's interesting because I have this double bond right here. And that is not part of the longest chain, but I need to include double bonds always in the longest chain. So I have 1, 2, 3, 4, 5. And that way of numbering 1, 2 is better than going this way, 1, 2, 3, 4, 5, because here I reached my double bond on carbon number 1. So I have pentene as a base name again, and then I have a branch right here, and this is an ethyl branch, and a branch right here, which is a methyl. So the ethyl is going to be listed first, so 2-ethyl. 4-methyl, pent, 1-ene. So 2-ethyl, 4-methyl, pent, 1-ene is the proper name for this one. Why don't you give this one a go, E, and see how you do on that. And this one doesn't matter which direction I number this in terms of the double bond. Each reaches at a 3. However, if I go this way, 1, 2, 3, 4, 5, 6, I reach a branch on carbon number 2, as opposed to the other way where my first branch is in carbon number 3. So I have 2 methyls and an ethyl here. The ethyl is going to go first because it's alphabetically first. So I have 3-ethyl, 2, 4, dimethyl. And then I've got hex, because I have 6 carbons in my parent chain, 1, 2, 3, 4, 5, 6. So I've got hex dash 3-ene. 3 because my double bond is on carbon number 3 right there. So that would be the full name for this guy. All right, another one for you to try out. Try this one out, line diagram, and see how you do. And on this one, have to go right to left for the numbering to get to that double bond as quickly as possible. Here, it doesn't matter if I go up or down. It's the same, so I'm just going to go up on that, which means that I've got 2 branches, one right here and one right here, that are both ethyls. So the name for this would be 3,4-diethyl hex 2-ene. So 3,4-diethyl hex 2-ene is my proper name for that one. Now I've got some alkynes, and I know a lot of examples here. Lots of examples. I mean, that's not such a bad thing. But why don't you, well, no, I got to do one alkyne with you to start off to show you the difference. So again, triple bond gets the priority. Okay, so when I'm numbering, I would go left to right on this. So I'd have 1, 2, 3, 4, 5, 6, which means that this is my methyl branch on carbon number 4. So I've got 4 methyl, hex 2 ine. 4-methyl hex 2-ine as a title. When I take a look at H, okay, my numbering for this could be 1, 2, 3, 4, 5, 6, 7, 8, or if I go the other way, 1, 2, 3, 4. So both ways are great for the triple bond. Okay, so now I take a look at which direction reaches a branch first. And the one that reaches a branch first is right to left, where I end up with a methyl on carbon number 2. When I go left to right, I have 2 branches on carbon number 3. So right to left is the correct numbering for this. 1, 2, 3, 4, 5, 6, 7, 8. So I've got a methyl, an ethyl, and a methyl. So when I am writing out the name for this, the ethyl comes first because it's alphabetically first. So I've got 6 ethyl. Now I've got 3 methyl groups, so I should have 3 numbers listed here. So lowest to highest, 2, 3, 6. So 2, 3, 6, dash, trimethyl, because I have 3 methyl branches. I should always have the same numbers and amount of numbers here as this prefix indicates. So trimethyl, and I have 3 numbers listed here, so that's good. And then it is oct, because I have 8 carbons in this parent chain. And then I have the triple bond on carbon number 4, so it's oct 4 ine, Y-N-E, which shows it's a triple bond. These line diagrams are a little bit tricky, and I'll tell you why. Where this triple bond actually is with how this diagram is done, this is actually representing a carbon at the end of that triple bond. And then this is also a carbon, here's a carbon, and here's a carbon. So this triple bond, right, where that ends, important to note that this is a carbon. So why is it drawn this way instead of being zigzaggy? Well, the stereochemical formula, how it is in 3D space, is that this actually is in a full-on line, right? We're looking at triatomic linear Vesper shapes on each one of these carbons. So it is all in a perfect line, which is why it's drawn kind of like this, but important to realize that at the end of that triple bond, I do have a carbon there. So that kind of counts as like a vertices or a point where I have a carbon in the line diagram. So when I'm numbering this, going from lowest to highest, it would be 1, 2, 3, 4, 5, 6, 7. So I have a methyl group here, a methyl group here, and a methyl group here. So how I would write the name for this is I would go 4, 5, 6, trimethyl, hept, because I have 7 carbons in my parent chain, 2 ine. And that would be my name for I. Awesome. So now let's go into the drawing aspect of this, now that you are a master of naming alkenes and alkynes. So for drawing it, just reverse the process. Draw a straight chain containing the number of carbon atoms represented by the name of the parent chain, and number the parent chain from left to right. Place the multiple bond between the number listed in the parent chain and the next highest carbon. That is something that is often done wrong. So important to remember that when you have, like, let's say 3-ene, right? That 3 is the first carbon that has a double bond. So the double bond is between carbons 3 and number 4 of that parent chain. Attach all branches to their numbered locations on the parent chain, and then add enough hydrogens to show that each carbon has 4 bonds. So a double bond counts as 2 bonds for that carbon, a triple bond counts as 3, and then fill in the rest of the hydrogens. So we're just going to do 2 examples here, a structural and then a line for each, so we can show it in 2 different ways. So when I have pent 2-ene, I would draw out my 5 carbons. I'm not going to actually number the carbons. I think we can do that without numbering, just realizing that it's left to right. So I have 1, okay, line 2, line 3, line 4, line 5. So there is my 5 carbons for the pent. I have that covered. Now let's deal with this 2-ene. So carbon 1, 2. So my double bond is going to go between carbons 2 and 3, because again, this is the lowest number for carbon, okay, that the double bond is on. So it's between carbon 2 and carbon 3. Now I can draw my methyl groups. So I have a methyl group here, right? 2, methyl group here, which is the third carbon, 3, and a methyl group here, which is the fourth carbon, 4. Now I fill this out with remaining hydrogens I need. So this carbon has 1 bond, so I need 3 hydrogens to get to 4 bonds total. This carbon actually has all 4, 1, 2, 3, 4 bonds. So I'm just going to lengthen that double bond to clean that up. Okay, here I have 1, 2, 3, 4. So again, I can lengthen this single bond to clean that up, but I already have 4 things on that carbon. Here I have 1, 2, 3, so I need 1 hydrogen to make that work. And then here on this carbon, I have 3 hydrogens. Okay, now I have 6-ethyl 2,5-dimethyl oct 3-ine. So maybe give that a try in your workbook and see if, oh, sorry, line diagram for this one. Whoops. So I'm going to have 1, 2, 3, 4, 5, 6. My double bond is on that second carbon, so it's going to be right here. So I'm just going to draw it like that. And then I have methyl groups on carbon 2, on carbon 3, and on carbon number 4. All right, now, why don't you try this one out in your workbook, see how it goes. So I've got 1 carbon. I need 8 in total. 2 carbons, 3 carbons, 4, 5, 6, 7, and 8. 3-ine, so 1, 2, 3. So my triple bond is going to be right here, okay? And it's going to be right there because it's going to be between carbons 3 and carbon number 4. Now I've got 6-ethyl, 1, 2, 3, 4, 5, 6. So I need to have an ethyl group right here. So let's go CH2, CH3 for my ethyl, right? 2 carbons in that ethyl branch. 2,5-dimethyl, so I need a methyl right here, CH3, 1 carbon. 1, 2, 3, 4, 5, and a methyl group right here, CH3. For these groups, it doesn't matter if I go up or down, right? It's the same connection, so it doesn't matter. This carbon now has 1 bond, so I need 3 hydrogens. This carbon has 1, 2, 3 bonds. I need 1 H. This carbon's good. It's got 4. This carbon's good. It's got 4. Here I've got 1, 2, 3 bonds. I need 1 hydrogen. 1, 2, 3 bonds. I need 1 hydrogen. 2 bonds. I need 2 hydrogens. And then finally, 3 hydrogens on this one here. Okay, let's talk about general formulas and then we're done. For an alkene, given that it's only 1 double bond, okay, then it's going to have the formula of CnH2n. So an alkane was CnH2n plus 2. So if I had, let's say, 5 carbons, then I have 2 times 5 is 10 plus 2 is 12 hydrogens. So in order for me to get a double bond, I need to lose 2 hydrogens, right? 1 from this carbon, 1 from this carbon to make that double bond. So for an alkene, the general formula is CnH2n. So if I have 5 carbons, I have 10 hydrogens. And then for an alkyne, you can probably guess how that's going to go. If I have a triple bond, I've lost 4 hydrogens, right, from an alkane, because this could have had 2 more without the triple bond if it was a single bond, and this could have had 2 more. So the general formula for an alkane is CnH2n minus 2. So whenever you have a double bond, you've lost 2 hydrogens. Whenever you have a triple bond, you've lost 4 hydrogens. I kind of call this like degrees of unsaturation or something. So that's just in order to come up with the formula. Like, for example, if I were to ask you, hey, what's the formula for this structure? You'd be quicker using a general formula than trying to count and add together all the hydrogens. If you count the carbons, right, which I actually would normally do from this, I have an ethyl, 2 methyls, and then octyne. So I've got 12 carbons. So given that I have 12 carbons and I have a triple bond, this is going to be H22, right? 12 times 2 is 24, minus 2 is 22. So I can come up with that formula really quickly by looking at the name, counting the carbons, and then using my general formula to figure that out. We're going to do more work on that in the future, just kind of something to quickly cover while we're in the topic of alkenes and alkynes. All right, that's it for this lesson. Have a good rest of your day.